All right. So I think we'll get started with session 2. This is a session on systems and measurements. There are a number of wonderful talks in the session. 3 of the papers talk about systems, about how we incorporate all that we've learned about issues of fairness, accountability, and transparency into building actual systems that might implement some of these ideas. And the 4th paper, the first one in fact, talks about the ongoing problems we still have with systems that are doing things we don't expect and that we may not want them to do, and how to monitor them to make sure they do it better. Now, unlike Hannah, I did not have a prior career in competitive rollerball, but I still will attempt to get people to stay on track and end their sessions on time. 10 minutes each, and we'll take all questions after all the 4 speakers are done. So without further ado, I'd like to invite the first speaker up, John Martin. Not these two.
Thank you, Suresh. My name's John Martin. Thanks for having me here today. I'm a graduate of Northeastern University and a software engineer in industry. And I'm here to talk about my first publication, ABN Testing in the Wild, which is some work that I did with Shan Jiang and Christo Wilson together up in Boston. So let's get started. What is A/B testing? Normally on the web, everybody visits a site and sees the same site. Some of you probably could guess that that's not always true. And one of the ways that it isn't always true is with an A/B test. A/B tests are when some variation of the site is introduced, and half of users, sometimes randomized, like in this example, see one variation, and based on some sort of metric of success, one of these wins out in the end when the test is over, and that variation is adopted moving forward. Everybody sees that version of the site. In this case, with a randomized audience and just a color change, it seems pretty benign, but these tests don't always have to shake out this way. Sometimes the audiences can be segmented more specifically by any host of attributes, one of which might be location. And these locations and other attributes can be built into more specific profiles, maybe to define a region, or even more specific things about a user, like maybe their gender, their age, or what kind of device they're on. This sort of hyperlocalization becomes more concerning in the context of price discrimination or a targeted political message, for instance. Another way that these tests can be concerning is in their content. Here's a contrived example of the New York Times, and one of the things they might test with an A/B test is a layout change. Again, this doesn't seem like that big of a deal, but they have full reign over the site, obviously, and another thing they could choose to test is a headline change, which seems more consequential. And in fact, they do actually do this, which I'll talk about in a second. So that brought us to our study, which has some broad questions, mostly because we just don't know much about what's going on with A/B testing experiments in general. They're not very transparent by design, so broadly we wanted to know how widespread are these tests, how are users segmented, and are there potentially any ethical concerns with the content of the experiments. We chose Optimizely as our lens for the test. Optimizely is a non-technical graphic web app that lets just about anybody build and deploy A/B tests. It's quite popular, and importantly, the way Optimizely is built is that these experiments and audience definitions are actually downloaded to the browser, so we were able to write a crawler to extract that data. And we can talk about how we did that. So we crawled the Alexa Top 1 Million looking for some reference to Optimizely. Found about 10,000 websites that had some reference, and then repeated regular crawls for 3 months last year, finding about 575 websites that were actively using Optimizely at the time. We did some quantitative analysis on the results. So we'll first talk about audiences. Audiences are those user segments that I mentioned earlier. 38% of sites define some sort of custom audience. It's important to note that just because a site didn't define a custom audience doesn't mean they weren't running a randomized A/B test where the audiences are split evenly. Most sites had very few audience definitions, but a couple sites had very refined audience definitions. These are some of the most popular segments or properties that we're segmented on. A lot of them are location-based, which is not too surprising. This tracking cookies is much more of like a black box, but we did see some data brokers plugging into there. As for the experiments themselves, about half of sites were running some experiment. That number also seems a little low, but it's, again, important to note. We ran these crawls about once a week, and a lot of these experiments are more short-lived than that, so we suspect we missed some things there. Similarly to audiences, about most sites were running very few experiments, and a couple were running quite a few experiments. And about half of all experiments were classic A/B tests with just one variation, but a couple had quite a few variations, and that's the N in ABN testing. Qualitative case studies. So a little bit more about how Optimizely works. The content of these experiments is basically a JavaScript payload that executes, which makes it very difficult to analyze at scale. So broadly, we're going to go into a three choice like case studies that we called out. But if you want to know more about that, I urge you to read the paper. One of which of these was advertising experiments. This is where people are being arbitraged between ad networks, and this has some tracking and privacy implications. Another was price discrimination. This happens where sites will offer people basically a discount or a different price of a product based on who they are, or perhaps randomly. We saw insurance companies doing this, and this is often disturbing for people to learn. Finally, article headlines. I'll actually get into this one. So I mentioned the New York Times earlier. They were one of the most sophisticated users of Optimizely in our study. 90 custom audience definitions, 91 experiments, and this is an actual example of a headline change that we observed. The first one reads, "Pope condemns atrocities of abuse in letter to Catholics," and the second one reads, "In a letter to 1.2 billion Catholics, Pope cites sex abuse atrocities." Just a couple of things to point out here. The term abuse has changed to a more pointed sex abuse, and there's a reference to a full 1.2 billion Catholics. So what's the big deal here? Basically, it's been shown that people can walk away with differing or even inaccurate understandings of the same content of an article just based on how the article is framed through the headline. This becomes especially concerning if the article has any kind of partisan content. So in conclusion, we were the first observational study of ABN testing in the wild. We used Optimizely as a lens, did some extensive quantitative measurements, and did a couple qualitative case studies. We've got some discussion. So first thing I want to know, or let you guys know, is we didn't observe any clearly unethical behavior in any of these experiments, but that doesn't mean it can't happen. These tools are out there, they're easy to use, and the only reason we were really able to do this study is because of the way Optimizely is built. But a lot of other tools are much more of a black box. We probably wouldn't be so concerned if sites were more transparent about the existence of these tests. Many of them don't even mention them in their terms of service. Another thing that's important to remember is A/B tests are tests on humans. And so we think respect for persons and consent should potentially be given for some of these more consequential tests. And finally, we wonder if the industry could look to some set of standards or training for how these tests should be conducted. With how easy these are, with how easy these tests are to build and deploy, it's easy to imagine that people with little training or perhaps even no knowledge of experimental ethics could build and deploy these tests to a large group of people. That's all I have. It looks like I'm pretty well under time. Thank you for your time.
Hi, my name is Meg Young, and I'm a PhD candidate and policy researcher in the Information School at the University of Washington. Today, I'll be speaking about a data trust model for data sharing on behalf of our interdisciplinary study team that includes urban planners, sociologists, and computer scientists. Our work addresses a set of practical data access problems we observed in Seattle, which we believe have implications for the computational research happening at FAT-STAR. We begin from the observation that data sharing is shaped by competing interests. Users want to protect their privacy. Firms that hold an increasing share of data are concerned that it will reveal their competitive business practices, whereas researchers require granular data for our work, and governments want to enforce compliance and safeguard equity in service provision. The public also wants visibility into policies and systems that affect them. In light of all of these constraints, the legal challenges to cross-sector data sharing also deserve some mention here. So in Washington state, most data sets shared with government by firms are public record, and there is no blanket privacy exemption that could support public-private data sharing. So as a result, firms have been very reluctant to provide data to government, even when required for new permits and new programs. Our work is set in the transportation context, which is interesting given rising pressures on infrastructure because many local governments are innovating in traffic management. For example, one app called Incentrip tries to gamify the commute experience with incentives to promote greener choices. Such programs often involve public-private partnerships with large data sharing needs for apps and real-time information. Fairness is also central here, as new programs affect how resources are allocated and for whom. So we think about this problem as a dilemma between two different models of data sharing, open and closed. In the open data paradigm, data is shared freely, but this could pose some privacy risks. Or on the other hand, the data could be aggregated to the point where it's not useful for most applications. We think that one effect of researchers relying on open data is that a preponderance of our work is focused on the data that's already available. For example, the COMPASS data set or the PredPal algorithm. It can also be very difficult to validate the data that firms proactively share. For example, Gay et al. Found a discrepancy between data provided by Uber's API and field data collected by the research team with respect to customer wait times by race. At the other extreme, in a closed data paradigm, rather than looking like this, where no data is flowing, instead, data is shared via pairwise agreements between data providers and recipients. But this model involves high transaction costs and lawsuits. For example, the city of Seattle requires Lyft and Uber to provide zip code level aggregate trip counts in order to receive a permit to operate. When this data was recently subject to a public records request, Uber and Lyft filed an injunction and a series of appeals that became a multi-million-dollar lawsuit to prevent this aggregate data from being released. The case eventually escalated to the state Supreme Court, where it was disclosed. But this example illustrates this risk perception that has significantly slowed cross-sector data sharing in Seattle and beyond. Firms are too unwilling to expose their competitive advantage. Even when researchers are able to get access to firm data, they're not able to pool it between firms, leading to siloed analysis. At UW, we designed and built an alternative that we consider to be an option for others caught in this data sharing dilemma. This data trust model, it requires the university to be the steward of sensitive data. Legal and technical controls help secure access to granular data from firms and place guardrails around how it should be used. Our legal agreements are designed to drive transaction costs down over time by using data sharing and use agreements that can be updated. We also leverage computational techniques to protect data via synthetic versions of data for use in research. Synthetic data is a technique being developed by Luke Rodriguez here in the front, my colleague at the University of Washington. which draws on differential privacy and causal approaches to amend causal relationships between sensitive variables. The intention is that instead of providing sensitive data directly to researchers, synthetic data makes a granular version of the data available that has the same schema and maintains fidelity to the original. Using synthetic data techniques, Luke and his collaborators have been exploring how it might be used to address gender or socioeconomic bias in data, as well as to protect individual and firm privacy. Moreover, synthetic data could be a useful resource in cases where using the original data is not necessary or prudent, such as for researchers still earning access privileges. Although our approach is based on medical data repositories, there are no analogous laws to HIPAA that would otherwise protect privacy in the transportation data context. The legal agreements we use are crafted in the public records context I mentioned earlier. And although the University of Washington is a public university, as a research institution, we are able to protect the repository as human subjects data. The university can take long-term responsibility for the content and the intended uses of synthetic data products and provide strict controls on who can access data, what version, and for what purpose. We currently have a pilot version of the data trust that manages data from 3 bike share firms in Seattle. Having access to this data has made a set of research agendas possible on equity in transportation service provision, bias remediation, and data ownership. Overall, we do think that this is a viable approach for others who need access to granular data for algorithmic accountability and fairness research. Rather than working within an open or closed paradigm, the data trust is intended to be a third way forward that uses legal and technical means together to protect sensitive data. Our hope is that this model will be adopted in other domains. Thank you.
Great. Thank you. I'm Aus from the University of Wisconsin-Madison, and I'm happy to be here in this nice weather. This is joint work with Sam Vinitsky, and the idea here is that we have assertions as in a programming language. As a programmer, I might write such an assertion to indicate that at this point in the code, the value of x should be greater than 0. And that's because I've designed the algorithm this way. I expect the value of x to be greater than 0. But code is tricky, and I may have made mistakes. So I state this expectation in there, and if it fails, then the program will yell at me and tell me that this doesn't work. Another example, I may be interacting with an existing data set or some API that's giving me information, and I may expect that the age attribute that the API is giving me should always be greater than 0, assuming there are no newborns in the data set. But you never know. Data may be corrupt, data may be dirty, and this assumption that I make about this data source may not be valid. So as the program is executing, what's going to happen is at some point it's going to hit this line of code, and the program will introspect and ask itself, is age greater than 0? And if it isn't, the program will crash or report something to the user or do something about it, essentially. Okay? So assertions are a ubiquitous means for programmers to state their assumptions and expectations, and pretty much any programming language that you pick up these days, it has a way of writing down assertions, writing down these assumptions, writing down these expectations. Okay? And it's a very simple idea, right? I mean, we take it for granted, but I think it's pretty profound because you can state in a very simple way, in a very clear way, what you expect the code to be doing at a specific point. And then the program introspects and looks at its own state and asks itself, am I doing the right thing? Okay. So this is extensively used in industry. There's even evidence, empirical evidence, that in projects that use assertions extensively, there's lower faults and bugs, etc. And the question we ask in this talk is, what about assertions for socio-technical systems? In other words, if you have a system that is making consequential decisions, what does it mean for us to state an assertion about this system? Okay. So we come up with the idea of fairness-aware programming, wherein you can specify the fairness expectations or definitions that this community develops and refines. You can specify them natively in the code, and then the program can introspect, and as it is making decisions in the wild, and ask itself, am I doing the right thing? So this is extensively used in industry. There's even evidence, empirical evidence, that in projects that use assertions extensively, there's lower faults and bugs, etc. And the question we ask in this talk is, what about assertions for socio-technical systems? In other words, if you have a system that is making consequential decisions, what does it mean for us to state an assertion about this system? Okay. So we come up with the idea of fairness-aware programming, wherein you can specify the fairness expectations or definitions that this community develops and refines. You can specify them natively in the code, and then the program can introspect, and as it is making decisions in the wild and ask itself, am I doing the right thing? So this is best illustrated through an example. 7 talks later, this is the first piece of code in the conference, so I should get an award. This is a classifier, and for the sake of argument, let's just imagine that it's making hiring decisions. It's receiving a resume of some person X, and it's deciding whether to hire them or not to hire them. Okay? So I, as a person who designed this classifier or trained this classifier or whatever, I probably read all the literature and did all the right things and followed the best practices to ensure that it satisfies some fairness definition. For the sake of argument, I'm going to use this definition. Whether you like it or not, this is just an example. This simply says that the rate of selection from minority applicants is at least 90% that of the rate of selection of the non-minority applicants, assuming for simplicity the population is divided into minority and majority. Okay. So this is great, works on my data, but how do I know that this classifier is fair in practice? Meaning once I deploy it in the wild and it's making decisions and affecting people's lives, is it still satisfying this constraint? Of course, this may or may not be true. The distribution, my data might be biased, may not be representative of the population, et cetera, et cetera. Okay, so in the wild, this may or may not be true. So what we do is we just write this fairness definition explicitly in the code. And what's going to happen is that as the classifier is running, we will be checking whether this holds or not. The runtime will be checking, just as with normal assertions that you might write in a program. So specifically, let's imagine that resumes are coming in the form of paper airplanes. People are submitting them, okay? And they're coming in a stream, and for some resumes, we hire the person. For others, we don't hire them, et cetera, and they're coming in a stream. And as the program is making decisions, it is learning something about the population, and it's learning something about itself. So the runtime of the programming language maintains empirical estimates of these expectation expressions. And then at some point, if it has high confidence that the assertion or this fairness specification does not hold, then it might stop working, crash, or just send a message to the developer or the data scientist or the VP, whoever deployed this piece of code that is making these consequential decisions. And this simply uses standard statistical tools that I'm not going to cover in this talk. The assertion language that we develop is pretty flexible. You can write a lot of things. So this is an example of classifier robustness or a form of individual fairness, which simply says that if 2 people are similar, then they should receive the same outcome most of the time. So this talks about the negation, meaning that the probability that they get different outcomes is different. So this is a form of what is known in the programming languages literature as a hyperproperty, because we're comparing 2 different people, and checking hyperproperties at runtime is more difficult than the group fairness property that I showed you earlier. And the reason is, if you have, say, made 4 decisions so far, and then you make the 5th decision, now that you've made the 5th decision, and in order to update your empirical estimates of this fairness property, you have to take this person and compare it to all other decisions that you've seen in the past. Okay? And as your past expands, you've seen more and more decisions, your introspection has to be longer and longer, because you have to compare this person to a very large number of people. Okay? That grows linearly over time. There are other examples of fairness definitions. I'm not going to go through them, but you can talk about, in this language, you can talk about, for instance, mutual information between different attributes and state some assumptions about the data that may or may not be true in practice. So to summarize, we developed this idea of fairness-aware programming. It's a very simple idea where you can natively state fairness assumptions in the code that you hope that your code will satisfy. And as a result, the code will actually introspect, and as it's working, as it's making decisions that are affecting people and affecting their life, it will ask itself, am I being fair? For some definition of fairness. And that's about it. Thanks.
I'd like to invite all the speakers to come up to the stage, and just a quick reminder, I am monitoring the Slack channel. We have a few questions already, and of course we'd like to take questions from anyone in the room as well.
Hello, my name is Cole. I'm from MailChimp, actually right down the street. And my question is directed at Meg concerning the data trust that you were speaking of. I know that you implied that you were going to be using legal restraints to make sure that this data trust didn't turn into something of a bad actor, but what type of considerations have you had thus far around whether or not putting all that data in one place would turn this data trust into more of a perverse actor acting in bad faith?
Thanks for the question. I didn't entirely gather the first part about bad actors. Would you say that part again?
My apologies. So, given that so much data is going to be in one place, I know that you mentioned that there would be legal restraints to make sure that it wouldn't be misused, but have you had any considerations around the perverse incentives of having that much data in one location and how that might impact, I guess, as a university that you discussed, used or portioned out that data?
Got it. So if your question is about having people inside, under the hood who are a risk to the data, that's of course a very valid concern, but the way that we're putting the repository together is going to be doing monitoring and logging of every interaction with the database such that there will be oversight and auditable trails of how people are interacting with the data and what uses they make of it. Thanks for the question.
Perfect. Thank you very much.
Hi, my name is Ashley Zhao. I'm from University of Notre Dame. This is also a question directed to Meg. I think that in your presentation you hinted at a sort of decentralization of data and encryption. Have you ever considered the solution of using blockchain in order to protect data and to share it across people?
I have to admit that personally I haven't given a lot of thought to blockchain. I could bounce that to one of my collaborators, but I think that it's really important to us that we make the data interoperable and usable even though it's coming in a distributed state, we are repackaging and remixing the data for various uses, and so it seems to me that maybe blockchain would encumber that process. Just a thought. Thanks.
Thank you.
There should be a prize for the first mention of blockchain at the conference. So, a question from the Slack channel for ours. So I'm going to read the question here. Does this work, your method you propose, for rank fairness as well as score or classification fairness? Are there fundamental limits to applying this idea in a ranking context?
The main assumption that we make, as with much of machine learning research literature, is that applications are coming from a population in an independent fashion. So whether it's classification or regression, that works. But we don't account for I'm not sure if we can model ranking problems exactly. Yeah.
Oh, hi there. My name is Stratos, and I'm a data scientist. The question is related to the proposal to store data under the custody of a trusted authority, which I think was the third option. And you mentioned differential privacy, so I have a two-part question. The first part is, are you suggesting that the data will be differential private before they actually stored by that authority, or is it the data models that get produced are differential private? So that's part one. In part two, a lot of people can claim that they actually do differential privacy, but there has to be some form of certification. Is there an authority that exists that can certify that the custodian of data is doing the right thing?
Great. I am a policy researcher on the project, so I'll direct you to Luke for a more in-depth answer after, but my understanding is that the data is going to be collected and stored in its original state, and that on top of that, differentially private techniques will be combined with causal approaches that are able to be paired together. And as to your question of who decides whether it's differentially private, I'll refer you to Luke. Thanks for your question.
Hi, I'm Josh Kroll from UC Berkeley. This is a question both for Aus and Andrew, and it's about category mistakes. So both of you have presented, I think, very interesting tools which have potential uses, and I guess my question is, to what extent have you considered how these tools might fit into some sort of process that a developer will use to achieve some normative end that they have? You sort of both alluded to this, but without maybe talking in an explicit way about what it would entail.
The way I view it is that you state all your assumptions in the code, and then once the code is running and it's making decisions, you will be receiving continuous feedback. So unlike with traditional assertions where if it doesn't hold, then the program crashes and burns, here you might be getting continuous statistics, and maybe if a certain threshold is hit, then the program will stop making decisions and tell you to look at the data or the new set of data that you've collected. One limitation of the work that I didn't have time to talk about, if I wanted to talk about limitations, would have needed to be a longer talk. But essentially that we don't account for feedback loops, right? I mean, because as you're making decisions, you may be affecting the underlying population and the kinds of people who are applying to the job, et cetera, et cetera. And this is not accounted for. So.
With that, we'd like to wrap up the session. I'd like to thank all the speakers and for their presentations today.